Up, dogs? All right, as promised, part two. Didn't get to it until now, 6:19 p.m., but I promised it. I'm gonna hold my end of the bargain up. All right, so let's get going on this. Number 14. Woo, woo. Part two, the part you've all been waiting for. We did talk about this one in class, but just in case you're like, bro, I didn't quite get that. I'm gonna throw it down right now. All right, so we have a 4x8 sheet of plywood, and if I were to try to cut out the largest 45, 45, 90 triangle, the largest isosceles right triangle, what could we do? Well, I'm going to label this as 4 foot and 8 foot. Okay. Now, if I were to draw in a 45, 45, 90 triangle, let's say I'm cutting right along here. Well, this would be 4 foot right here. And let me actually do my little fancy teacher brackets. So that's 4 foot. Because this is an isosceles triangle. Those are congruent. It's a right triangle. This is a 45, 45. 90-degree triangle. All right. It looks like perhaps I'm only using up half this rectangle. I could possibly even go, couldn't I create another 45, 45, 90 right here? Where this is 4 foot and this is 4 foot, right? And that's 45. And here's the deal. If, actually, let me go with a red. Okay. This angle right here, that's 180 degrees. I've already used up 45 and 45. I've got 90 left. So now I've got this 90-degree angle here. If this is a rectangle, well, these are both 45 here and 45 here, right? Because I already had 45 accounted for. So now I have this even bigger 45, 45, 90 triangle. So that guy's 8 foot because this is a rectangular piece of lumber, right? There's a lot going on here. I'm going to pull this triangle off, okay? So we've got 8 here, 90 here. I don't know what this is. This is 45. This is 45. And I don't know what this is either, right? But because it's isosceles here, those are the 45s, right? The X and the Y are going to be congruent. So I only need to get one of them, and I get both, all right? Well, I can set up my proportion for my 45, 45, 90. I've got across from my 45s is X, Y, and then I have across from the 90 is 8. So now it's a more manageable problem. I've brought it into my 45, 45, 90 triangles. We're good to go. I'll just go ahead and solve for y since it's, right next to the one that we know stuff about. So I've got y root 2 equals 8. Divide by root 2. Those are gone. I have y equals 8 divided by root 2. Now I need to rationalize this. So I have root 2 over root 2 equals 8 root 2 over 2, which is 4 root 2. Now, some of you are noticing some shortcuts here. You're like, I know I can just get to 4 root 2. I know what it's going to look like from there. That's cool as long as you have some work shown. But know that if you make a little mistake, you're not going to get that partial credit. All right. So that's one of the dimensions. It's asked for what are the dimensions of the largest triangle he got out. So I need all 3 dimensions because there's 3 sides to a triangle. So our final answer would be 4 root 2 by 4 root 2 by 8. And if we wanted to put feet on each one of these, that's cool. I know the 4 root 2s look kind of weird. This is application. I would allow decimals in an application problem because a lot of us have struggled with the rationalization. I decided to show that here. Okay? Something that's maybe a little more likely on your test tomorrow would be something like number 15. All right? Number 14 there, definitely a challenge problem. But if you can do 15, you should be all right. So we have a 20-foot ladder leaning up against a house. Okay, so let's say he lives in a greenhouse. Not like the kind, well, maybe it'd be a greenhouse. That'd be kind of cool. Glass windows and stuff. Whatever. All right, so this ladder here, we'll make that purple. So we have a 20-foot ladder. And then it's a 60-degree angle with the ground. So that'll be 60 right here. And then how far away from the wall should it be set to make that 60-degree angle? Okay. Sorry, I'm kind of reading this in a weird way. So that is X. I feel like I need to shrink this down and redraw this. Don't have a whole lot of room. There we go. All right. There we go. So that length right there is what we want, X. Okay? And then it also says, if a window is 18 feet above the ground, will the ladder reach high enough to work on the window? So perhaps I also want to know what this length is. I'll call it y. And hopefully that is a right angle. Our building is perpendicular to the ground, right? Let's go ahead and assume that the house is built correctly. Okay, wonderful. So now I have this 60-degree angle, this 90-degree angle. Would that make sense that this is then 30 up here? It absolutely would. So I'm dealing with a 30, 60, 90 triangle. So 30, 60, 90. I have 1, root 3, and 2. Well, what is across from my 30-degree angle? That would be my x. What's across from my 60-degree angle? That would be my y, so that goes over the root 3. And then what's across from my 90-degree angle is going to go over the 2, which is 20. Woo! Awesome. Awesome sauce, indeed. All right, so now I can cross multiply and solve. I'll deal with the x first. So we have x over 1 equals 20 over 2. So 2x equals 20. Divide by 2. X equals 10. So 10 feet away from the wall, or from the building. All right. So that's part 1. Part 2, I'll change colors, is going to involve these two. So I'll cross multiply, I get 2y equals 20 root 3. Divide by 2 again. Boom, that's gone. And I get y equals 10 root 3. Now, it says it's 18 feet above, right? The window is 18 feet above the ground. Perhaps I need to bust out my TI-84 for this one, because I don't know what 10 root 3 feet is, right? So I'll type in 10 times the square root of 3 in my trusty TI-84 plus graphing calculator, and I get 17.3 feet. If it's 18 feet above, you're going to be like right up there. So math-wise, when we're like, oh, is it enough or not? I would say not going to reach the window. Could you possibly get up there and be able to reach it pending your height? Yeah. So in math world, I would just say, how high up is the ladder going to reach? But it's a nice thing to think about is, hey, can we work on the window? Honestly, this one kind of depends on the person. Okay. Cool. Awesome. Awesome sauce. But if you can get this, you're all set. All right. Next one. So Drake is trimming the exterior of his house with 5.5-inch wide trim. All right. He has a 12-12 pitch roof. So when we have a roof like this, if we have your roof line is going to look something like that. Okay. And when we're trimming that roof line, you're going to end up having some trim that comes up here and here. And then you end up doing what's called a miter cut, where you're going to have this go vertical here. And then what you actually have are a couple 45-degree angles up there because of the pitch of the roof, the 12-12 pitch, how it's going up on a 45. When those angles meet, they form a right angle, and you cut each one to a 45. So let me back out here, because this takes a bit of thinking in construction and also math. So essentially, I'm going to be taking this wonderful, wonderful piece of stock trim, we'll say. I'm going to draw this up a little different than what we did in class. This stock trim is 5.5 inches, okay, wide. Now, to get this situation going on up here, I'm going to take my either circ saw or miter saw, and I'm going to cut a 45 on it, okay? And I want to know, that was a terrible teacher bracket. What happened? That's a little better. I want to know, what's the length of that cut? Well, if we look at what we just created here, I have a right triangle. And not only just any kind of right triangle, I have an isosceles right triangle, it looks like. So if I'm cutting this at a 45, that triangle right there, I'm using technology. Oh, boom. Well, I already know it's going to be a 45, as we said before, because of the angle of the roof. So 45, 45, 90. I want to know what this is, and I already know that the 5.5 is right here. And if those angles are congruent, this is 5.5 as well. So now I can set up my proportion for a 45, 45, 90 triangle. I've got 5.5, 5.5, and I've got x. X is the length that I want, okay, in this problem. So I'm going to have cross multiply with, how about these two right here, since they're next to each other. The other one's already solved for. Cool. I'm going to have 5.5 root 2 equals x. And I'm going to go ahead and plug this into my calculator. It is a wonderful application problem. And I want to know what the actual on a tape measure would be. So x is going to be 7.778. So 7.78 inches. Cool. So that's the length of my cut. Now, the reason why this would be important is you want those cuts to match up. You can't match up a 45-degree cut with one of your stock flat edges of 5.5. It's going to hang over a little bit. Okay. Again, not necessarily a question I'm going to ask here on this test, but it's a good way to tie in the construction aspect to our math. Love doing that, you know, because you always get the question, when am I going to use this? Boom. America. All right. Last one. Another ladder problem. Definitely the more common one you'll see on your test. Some of these 45, 90 ones were a little bit trickier, right? It takes a little bit of construction knowledge, but I still like to throw it in there. Okay. 15-foot long ladder, set at 60-degree angle with the ground and fully extended to the 15-foot max length. So it's a little scary getting up on the max length of those ladders. All right. How far away from the wall should it be set to make a 60-degree angle with the ground? How far up the wall will it reach? Cool. So I'm going to draw that wonderful wall again. Apparently, we are also dealing with the green house. Then we got the green ground, right? And there's this building. Cool. Awesome. Now I'm going to have another purple ladder. Whee! And that is a 15-foot ladder. And it makes a 60-degree angle with the ground. This is going to be a right angle because we are hoping that the building is built properly. And that leaves me with a wonderful 30-degree angle right here. Okay. How far away should it be set from the building? We'll call that X. And then the last one will be how high up will it reach? That'll be Y. Cool? I love it. I'm going to erase that so that it doesn't get in my way. Okay. Maybe we'll just say the building is a rectangular shape like that. Yay. Cool. All righty. Let's go with our super proportion here. (30, 60, 90), 1 root 3, 2. Across my 30, I've got my X. There's the X. Get rid of that. Cool. All right. Across my 60, whoop, there's my Y. And then across from my 90 is the 15 feet. Okay. So now, cross multiply and solve. I'm going to start with the X over 1 equals 15 over 2. If I cross multiply, I get 2X equals 15. And that would divide by 2. I get X equals 7.5 feet. So 7.5 feet from the ground. From the base. Base of the wall. Cool. Now let's solve for Y. Same kind of process. I'll go different colors so we don't get them mixed up. So I got 2Y. Actually, let me write out the proportion for you. Y over root 3, 15 over 2. And then I'm going to have 2Y equals 15 root 3 divided by 2. I get Y equals 15 root 3 over 2. I can leave it as that. I'm going to go ahead and plug that into my calculator. 15 times the square root of 3. And then I'll divide that by 2. Or you could do like 7.5. You could also do this, 7.5 root 3. You may have already been like, well, I know 15 over 2 is 7.5 from the last one. Absolutely. Either way, you're going to get Y equals 12.990. So how about 13 feet? I think that is plenty accurate for a ladder. About 13 feet up. Had it said 1 decimal place, you'd have to round it up to 13 anyways because that second 9 rounds it up. If it said nearest hundredth, 12.99, but there we go. We got it. That's awesome. Fantastic. I hope these last 4 problems help and you guys enjoy the video. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. Yo, Ro. Don't forget your calculators tomorrow. And yeah, have a good one. See ya.